Hello my dear students. So welcome back to NEET world. So today we will be discussing the chemical kinetics numericals. Okay. So in the last class also, in the last session also, I have covered few numericals related to this chemical kinetics. I hope you are following the classes daily. So these live sessions are very useful if you follow them regularly. Okay. So make proper notes out of it and also practice the questions once after completion of your chapter. Okay. Now here I will be showing you few questions. If you have followed the classes previously, you can easily answer this kind of questions. So look at here, when the initial concentration of reactant is double, the half-life period of a zero order reaction, what happens to half-life, T half of zero order reaction, how it is related to initial concentration of the reactants. So by knowing that, you can able to answer this, very easy, right? So this is a NEET 2018 question. So how can you answer? So first look at here. So T half of zero order reaction directly proportional to initial concentration of reactant. How do we got this relation? So this relation will be from its integral equation. What is the integral equation for zero order reaction? So time required for this reaction will be given as T is equals to x by K naught. K naught is rate constant for this zero order reaction. If you don't know how we have derived this, just watch the chemical kinetic 2 session 2 in this playlist of this channel. You can able to get all these things. Okay. So now X is the concentration of product formed. So now I am saying A is the initial concentration of reactant and forming some product P. Okay. If A is the initial concentration at a time T0, after some time T half I am saying, it means concentration of reactant will become A by 2. If this is A by 2 and 1 half is here, this is also A by 2. So our X is also how much here? X is also A by 2. So I can take X equals to A by 2 into K naught. Now this is what the T half of a reaction. This is what we got, T half. From this only we got T half of a reaction. T half is equals to what? A by 2 K naught for first zero order reaction. Okay. So from this T half, how it is related to initial concentration? Directly proportional right now. So what they are saying, when initial concentration is doubled, so if A is doubled, so this is also doubles right now. So because they are directly proportional with power 1, it means what? They are directly proportional, means if it increases one time, this is also increases one time right now, like that. Okay. If it increases 2 times, this is also increases 2 times. See, doubled means if this is double, this is also doubled. So what I can say, so T half is also, the half life period of zero order reaction is also what? Double. So you can take option number 2 as your answer. Hope it is clear, right? Let us move forward with one more question. Now look at here, we have energy profile diagrams. Okay. So now select the correct diagram for an endothermic reaction that proceeds through 2 steps with the second step as a rate determining step. So now how can you answer? First of all, they are saying endothermic reaction. So endothermic reaction means energy of product is greater than energy of reactant. It means heat is absorbed during the reaction, therefore energy of product is greater than energy of the reaction. So look at the graphs, eliminate the one which is exothermic, eliminate those reactions. See, this is the energy of starting material. Okay. So this is the energy of starting material, reactant here, and this is the energy of product. Okay. So now look what I told you for endothermic reaction, energy of product, potential energy of product should be greater than potential energy of reactant. Therefore delta H becomes, enthalpy change for this reaction becomes positive for endothermic reaction. Delta H should be positive. In order to make it positive, delta H is equals to summation of enthalpy of products minus enthalpy of reactants. So if this is enthalpy of product is bigger, that is bigger than the enthalpy of reactant, then we will get delta H positive. So that's why what I am saying, in this profile diagram, so enthalpy of product should be, energy of product should be greater, but here it is lesser than the reactant. It means this profile diagram is for exothermic reaction. So this is not our option. Okay. So now look at here. So just make a line like this. See, this is also for exothermic reaction right now. So eliminate these 2 things first. Okay. So now out of these 2 things, so now look at here, the fourth statement, fourth graph is looking like perfectly endothermic. Why? Because see, energy of product is greater than the energy of reactant. Therefore, delta H will be positive, and they are saying rate determining step is second step. So, for a rate determining step in a given reaction, if there are multiple steps, the slowest step in the complete reaction is considered as rate determining step. See, it is having more energy gap from here when I compare with this. So, now see, from here to here one step, from here to here second step. So, more energy gap means it is slower now, yes. So, it is having two steps and this is having higher energy gap. So, I can say, and enthalpy of product is greater than enthalpy of reactant. So, delta H will be positive in this case, and what I am saying, it has more energy gap right now. So, I can say this is rate determining step or slowest step in this reaction. So, rate determining step is second step. So, proper answer for this will be option number 4. Hope it is also clear right now. Yes. Let me move forward with few more examples. So, look at here. The rate constant for a chemical reaction taking place at 500 Kelvin is expressed as K is equals to A into e power 1000. Okay. Now, they are asking activation energy EA. They are asking activation energy for this particular process. Temperature mentioned as 500 Kelvin. So, just use the Arrhenius equation. K is equals to A e to the power minus EA by RT. So, try to correlate these two things, try to compare these two things and try to get the value. I am expecting answer from you in the comment box. Just feel free to answer this. Just give a try once. So, look at here. How can we relate these two for solving or for getting this EA activation energy answer? So, just try that. Yeah, anyone in the chat box? Yeah, anyone in the chat box, please try to answer that. Yeah, I am looking into the chart. Alia. Hi dear. So, just try to answer this question. Yeah. So, now look at here. So, how can we answer? So, option 1 is incorrect. So, I will tell you how to do this. So, look at here. So, just compare. So, what I hope you are clear with this question first. See, once again read. The rate constant for a chemical reaction is taking place at 500 Kelvin is expressed like this. The activation energy of this reaction is. So, we need to know this activation energy by comparing these two equations. Just use Arrhenius equation to solve this question. So, look at here, we have K here, A here also. Now, this exponential term, what we have? E power minus 1000. Here e power minus EA by RT, right? So, take minus 1000 will be is equivalent to minus EA by RT. Yes or no? By comparing these two things, we will get like this. Yes or no? See, e power minus 1000 will be equals to e power minus EA by RT, right now? Yes. Now, you can remove this negative signs here, okay. So, I just want activation energy EA, so that I can multiply 1000 with R into T, right now R into T I can do like this, right. So, after this what I can do? After this what I can do? So, here 1000 as it is I am writing. So, our answer should be in respective of kilocalories or calories. Okay, let us take what R is equals to how many calories? 2 calorie per Kelvin per mole now. Okay, in terms of calories, I can write in terms of kilocalories 2 power minus 3 kilocalorie per Kelvin per mole. Okay, like this also we can write. Okay, so if it is asking in terms of joules, you need to use R equals to 8.314 joule Kelvin inverse mole inverse. Okay, these are the two important units you should remember for R. Okay, so now right here 2 into 10 power minus 3, okay, in kilocalorie per Kelvin per mole. Okay, and what is the temperature mentioned here? 500. So take here 500 Kelvin. Okay. So now try to simplify this. Very easy. You are almost done with the answer. So this 1000 I can write 10 power 3 plus 3. So this 1000, this is 10 power minus 3. I can remove them right now. Okay. So next, what are the other units? See, here we have Kelvin inverse. Kelvin is also removed, so that we are getting our answer as kilocalorie per mole right now. So how much? EA equals to 2 into 500. So 1000 kilocalorie per mole. Right now this is what, this will be our answer. So look at here, where do we have option number 2 will be our answer right now? Yes, right. If it is clear, just click on the like button. If not, you can feel free to ask me in the chat box. Yes. Yes sir, understood. Yes. Yeah. So next question. See, yeah. So I just want to ask you one question. Like, consider one hypothetical case where A and K has to be equal. So how can I make this in Arrhenius equation? So what are the conditions that makes K and A are as equal? What are the conditions I can make? So look at here. So K equals to A into e power minus EA by RT we have right now. So here, so I just want to make this value as 1. Therefore K and A will be equals to 1. It means, what are the possible things we have? So either EA should be equals to 0, therefore something by 0 will be 0 by something will be 0, so e power 0 will be 1, therefore K equals to A it will become. Yes or no? I hope it is clear what I am saying. If activation energy is equals to 0, what happens to this equation? K is equals to A into e power 0 by RT. It means something 0 by something will be what? 0 only now, so it will become e power 0. So e power 0 means something power 0 will be 1. So K will be equals to A in this case, right? So is there any other condition that we can make? Yeah. So now either temperature tends to infinite, or yeah, this is the other condition we can make. Okay, if something by infinite will be also 0 now, so in that case also K will be equals to A. So these are the ways they can also test us, like what are the condition in which K equals to A, rate constant K will be equals to Arrhenius parameter A. Okay, so like this also they may ask. Okay, next here I have one more question. Yeah, look at here, effect of temperature on a rate of a reaction. Try to read this question. So try to read this. See, the rate of a reaction is doubled. See, rate of a reaction is doubled, just underline the doubled, for every 10 degrees rise in temperature. Okay, the increase in rate of reaction as a result of temperature from 10 to 100. So what is the difference? So 10 degrees Celsius to 100 degrees Celsius it is raised. Okay, so now at 10 degrees Celsius I am saying rate of reaction is R1, then I am saying R initial. Now I want what is R final here. So R initial at temperature 10 degrees, R final at temperature 100 degrees. Okay, so now I want R final in terms of R initial. How many times it is raised? So this is given from temperature coefficient. We discussed now temperature coefficient. Just a minute, I think it is blurred. Yeah, let me check it once. Yeah. Yeah. So I am saying here I want R final. It means how many times rate of reaction increase when we compare with the initial rate when we increase the temperature. So take this formula. So R final by R initial will be equals to mu to the power delta T by 10 degrees. Why I am taking like this? So look at here, they told us for every 10 degrees rise in temperature, rate of reaction will be doubled. Okay, so that rate of reaction is doubled, they are saying now, that is called temperature coefficient. Okay, so I can say temperature coefficient mu is equals to T. Okay, so I want R final, that is at 100 degrees. So temperature coefficient is 2 to the power, what is the change in temperature? So 100 minus 10, so it will be 90. Okay, by what is it, 10 degrees rise now for 2 times increment, yeah, take it here delta, that's why I taken 10 here. So it will be, what it will become? So R initial here 2 power 9 into R initial, that will be R final. Hope it is clear. Now 2 power 9 is how much? It will be 512. So R final will be 512 times of R initial. So this will be your final answer. So check, so where do we have? So option number 2. So final rate will be how many times? R final will be equals to 512 times of initial rate. Okay, with a rise of 10 degrees Celsius, with rise of 10 to 100 degrees Celsius. Hope it is clear. Yes. Okay, let us move forward with few more examples. Okay, now this is clear now. So just try this question. I am going to give you one more question here based on this explanation. So if you are not aware about this topic, just watch our playlist. Okay, I have discussed effect of temperature. Okay, so now just tell me, for a reaction I want answer for this from your side. For a reaction, for every 10 degree rise in temperature, rate of reaction increases by rate of reaction tripled. Okay, I am saying tripled. Then what is the increase in rate if temperature changes from 30 degrees Celsius to 90 degrees Celsius. So how do you do this? Anyone in the chat box? I want answer for this. Whatever the concept I have used for this question, try to use this same concept for this question. See, I want R final, that is at 90 degrees Celsius. I have given at 30 degrees Celsius as R initial, and I want R final, that is at 90 degrees Celsius. Okay, so now just use this formula. So what I told you in the previous question, it is doubled, I have told you, but in this question I am saying tripled. So temperature coefficient mu will be how much here? So 3, that's it. Okay, so now what you need to take? R final by R initial will be equals to 3 to the power delta T, how much? 30 minus 90 minus 30, that will be how much? 60, right now 60 by, so for 10 degrees rise now take the 10 degrees here, that's it. So your answer will be something like this. So R final will be 3 power 6 times of R initial. So this will be your answer like this. Hope this is also clear right now. Yes, if it is clear just tell me. If not, you can ask me, I will repeat. Okay, yeah. Yes, let us move forward. Yeah, so look at here, yesterday also I have discussed this kind of model question. So look at here, a hypothetical reaction A2 plus B2 gives rise to 2AB follows the mechanism as given below. These are the 3 steps, very easy and important. Look at here. Okay, the order of the overall reaction by rate determining step method, RDS step. So what is rate determining step here? So that is the slowest step taking in this reaction. So there are 3 steps in the reaction. but the slowest step is this second step, right now. So rate determining step is this second step. Okay, so from this you should write rate of reaction will be equals to K into some rate constant K into concentration of A into concentration of B2. Okay, but always remember that, so in the rate equation or rate law, always you should involve only reactant. If there is any substitute like any intermediates are there, those should be removed from the reaction, I mean this rate law. So what is our reactant here? A2. So it means your answer should be something like this in terms of K into A2 only. It should be like this, but we have some other thing from this rate determining step. So you need to convert this equation in terms of this A2. So how can you make? How can you make? That will be your big question here. Okay, so how can you make that? So just take here from the first step, what I can say, see this is our rate equation. So how can you make this? So A2 into B2, right now. So this is what our rate law from here, first from this overall reaction. Okay, these are the two reactants we have. Okay, so you need to make your rate equation like from the slow step, you need to make in terms of this manner. Okay, so now how can I make? Already we have B2, but it should not be A here, it should be in terms of A2. So how can I make? So for this equilibrium reaction, so I am writing K1 equals to concentration of product by concentration of reactant. That means A into A square, it is concentration of A square by A2, right now. So from that I want only A. So I can write K1 into A2, K1 into A2. Okay, so I am sending this square from here to here, it will become root, right now. So put this value in this equation, what happens? Rate is equals to K into concentration of A is how much? Root over K1 into root over A2 power, like I can say root of concentration of A2 into B2. Like this I can write concentration of B2. So K is a constant, K1 is also constant now. So product of these two will be also a constant. So I can write now rate will be equals to something like K dash I am writing multiplied with A2. Root means I can write 1 by 2, yes, and concentration of B2 I have, right. So here power 1. So what is the, see now this equation is in terms of A2 and B2. So this is the perfect representation of rate law from rate determining step. So now what are the powers we have with respect to A2 and B2? So half. So it means half order with respect to A2 and one first order with respect to reactant B2. Okay. So what is the total order? So just add these two numbers, half plus 1, that will be 3 by 2 will be your order of this reaction. The total order of this reaction is how much? 3 by 2. So look at here, option number 3 is given as 3 by 2. So that will be your answer. Yes, tick that answer. Okay, yes. Okay, let us move forward. Hope it is also clear. Yes. If not, just go back, watch it. Go back, watch it, so that you will be clear with the concept. Yeah. So next, look at here. For a reaction A to B gives rise to product. The following data were provided. This is the data provided. The rate constant for this reaction in the standard unit is. So how can you solve this? So rate constant they are saying. Rate is given, concentration of A, B also given. So how can I write rate is equals to something like K into concentration of reactant to the power its order, and concentration of reactants B is also there to the power its order. Okay, it's individual order. Like this is the best or the standard way of taking the reaction. Okay, rate law. Now here I have concentration of A, B, here data is given for A and B, and rates are also given, but they haven't provided what is the order of this reaction. If I know their orders here, by putting all the values, I can able to calculate this K value. Right now they are asking for K only, rate constant. So what is our primary duty now? We need to calculate this Mn from the given data. So look at here, how can we calculate this Mn? See, Look at here, I want to calculate M, that is for A, order of A. How can we calculate? See here. So while doing this, look at the data. See, concentration of B is being constant in 2-3 readings right now. So here it is being constant. It means there is no change of concentration of B in this case. But change of concentration of A is there here. So it is becoming 0.02 to 0.04. It is multiplied with 2 right now. It means concentration is increased 2 times. Here when concentration is increased 2 times, rate is also increased 2 times. Just check here, 2 4 to the 8. It means if this is increased 2 times, this is also increasing 2 times. It means rate is directly proportional to concentration of A. Okay, if it is something like 4 times, I should take it as 2 power 2, but it is same number of times. If it is increasing 2 times, here also increasing 2 times now. So what is the power here? 1. So it means what is the value of M? I can say M is equals to 1. That is order with respect to A is 1. Okay, now this is like M value we got. Now we need to calculate this N value right now. So look at here. Look at here again. If you look at the data, like A, these first two values are constant right now for A. It means there is no change in the concentration of A in 192 readings. But for second, for B, so if concentration increased 2 times, look here also rate is also increased 2 times. It means here also rate is directly proportional to concentration of B. It means the order with respect to B also 1. So N value is also 1. Therefore we got Mn values right now. So once if you are able to identify Mn values like orders, then easy it is. So I just want K now. So I can write K is equals to rate by concentration of A to the power 1 and concentration of B to the power N, means that is also 1. That's it. Okay, take any of the value and try to substitute here. So you are going to get. So take the first value, they are little bit easy and simple. So 2 into R is initial rate, how much? 2 into 10 power minus 2, and concentration of A is how much? 2 into 10 power minus 2, I can write 0.02 as. Okay, and concentration of B is also 2 into 10 power minus 2. I am substituting here that values. Now look at these, try to simplify. So 2 into 10 power minus 2, 2 into 10 power minus 2 I can remove. So we have 10 power minus 2, I can write 100 by 2 right now. So this is 2 we have. So this is how much? It is 50. That's it. So what is the rate constant for this reaction? It is just 50. So option number 4 will be our perfect answer for this question. Hope it is also clear. Yes. Yeah. So if you are new to this channel, guys, those who are watching this video for the first time, if you are new to this channel, just click on the subscribe button so that you will get daily updates. You can get all the subject, chemistry, physics, mathematics for MPC students, I mean JEE students, and biology for the NEET students. Okay, and also helpful for your other entrance exams like EAPCET, KCET, or any other state level entrances too. Okay, so just click on subscribe button, and if you are really like following the class properly, just click on the like button also. Yes. Okay, let us move forward with one more question here. Yeah, this is also very important. See, all the questions that I have taken are PYQs. So look at here, very easy. This is a rate equation, like chemical equation they have given, and they are saying for this reaction, if BrO3 bromate ion we have now, the decrease in the concentration of BrO3 minus is with change in time is given like this. Okay, then they are asking us what is the change in concentration of Br2. So this is very easy question and important model for all JEE, NEET and EAPCET. Look at here. So when reaction is given, so you need to write change in concentration of reactants like dr by dt, okay, will be equals to change in concentration of product dp by dt, like this. But we know during the reaction concentration of reactant decreases now, so reactant side you put negative sign, and during the reaction concentration of products increases now, you put here positive sign, like this. So minus dr by dt equals to dp by dt. This is a foundation first. Okay, if I say the reaction is taking like this, R is giving rise to P, you should write like this. Instead of saying R is giving rise to P, I am saying 2R is giving rise to 3P. So in this case what you need to do is, whatever the stoichiometric coefficient here we have, so try to write it like this. So stoichiometric coefficient in this denominator like 1 by 2, and here also I should write 1 by, what is the stoichiometric coefficient for product, 1 by 3, like this. So apply this concept over to this question, so you are going to get this easily. So here BrO3 minus is a reactant side now. So what is the coefficient here we have 1. So 1 by 1. So I should write rate is equals to minus 1 by 1 concentration of BrO3 minus by dt. This is reactant side. Okay, because that data only they have given. And product side we have bromine now. So dBr2 by dt. Okay, product side now positive, and what is its coefficient here we have 3, right? So write here 1 by 3 and with a positive sign here, here negative sign. Hope this is clear. Now they are asking the value of this thing dBr by dt, change in concentration of bromine with respect to time. So now they have given this value, right? So what is the value mentioned? 0.01, 0.01 is mentioned. So just send this 3 here into 3. So you are going to get your answer as dBr2 by dt will be equals to 3 into 10 power minus 2, or I can say 0.03 will be your answer for this question, dBr2 by dt. So look at here, option number C will be our answer, right? Right. Hope it is also clear, right? Yeah. So clear now? Yes. So take a note of it. Then let's move forward with one more question here. Yeah. So look at here, whatever the question that I have explained before question. So last second question. So what I told you, by looking at the values we can able to find their orders. The following data were obtained for a chemical reaction that is given below like this, okay, and the data concentrations are given, rate is also given. We need to calculate order of the reaction with respect to NO. So here we have, this is a reactant, we need to explain its order using the data, we need to answer that. How can we do? See here concentration of H2 is being constant. So now look at these values like concentration of N2, how it is varying and how rate is varying with the concentration of NO here. See here 10 power minus 5, 10 power minus 5 it is same, but here 8 becoming 24, 8 3 is a 24. So as concentration increases 3 times, let us look at the rate. So this is also, I can write 21, this is 21 into 10 power minus 9 right now. So rate is also increasing how many times? 7 becoming 21, this is also 7 3 is a 21. So as concentration increases 3 times, rate is also increased 3 times. So what I can say, the rate or the order with respect to NO will be how much? It will be 1. It is increased 1 time, this is also increased 1 time. It is increased 3 times, it is also increasing 3 times. So order with respect to NO will be 1. So your answer should be 1 for this question. Hope this is also done. Yeah. So this is about the session, and in the upcoming sessions and again and everyday live, everyday evening I will be coming live for almost 1.5 hours. Okay, so you can join those sessions where I am going to discuss chemistry for your NEET, JEE and EAPCET from very basic. Already started these live sessions and it will be around 6:30 or around 5:30. Okay, depends upon this schedule. Okay, so you do not skip that, try to join them every day, and if you are new to this channel, just click on the subscribe button so that you will get every updates from our side. Okay, thank you.